Hi friends, a pleasant good afternoon to one and all. First of all, let me thank you all who are presenting here for my presentation. First of all, let me introduce myself. My name is B. Arun and I am pursuing my 11th standard at the TTWREIS Khammam. And today I am in front of you to share my little bit of knowledge about the concept which states as whatever goes up must and should come down. And before going to explain my topic briefly, I would like to share few of my life experiences with you, which are very familiar for you. One day, when I was at my village, I had seen a woman who is playing with a baby by flying the baby into the sky and catching back the baby and making the baby to smile. I was amazed when I had come to know that the baby is coming back to her hand after few seconds is because of a scientific reason hidden behind it. I think you are very much curious to know what is that scientific reason hidden behind this mother's love, isn't it friends? Now let me share another experiences with you, that is the rain. I think every one of you loves the rain, isn't it friends? And we feel very eager and enthusiasm to play in the rain and to see the rain. If you look at the diagram of the picture, we can clearly note that the water droplets are dropping from the clouds towards the ground. And the general question which always arises in every learning mind is, why these water droplets are dropping from the clouds towards the surface of the ground? Why they are not flying away into the sky? I hope you might have noticed the topic about which we are going to discuss today. Yes, you are absolutely correct. Today we are going to discuss about a wonderful chapter in physics, that is the gravitation, and few main concepts in the gravitation. Firstly, let me define what is gravitation. The tendency of any material object to attract towards the center of gravity is known as gravitation. Or in simply, we can define it as the force of attraction between two massive objects in the universe is known as gravitation. Now, let me pose you one question. What is the use of this gravitation in our day-to-day life? Do this gravitation play a major role in our day-to-day life? Yes, you are absolutely correct. This gravitation plays a vital role in our day-to-day life. Whatever the work we are doing, such as like walking, such as like jumping, such as like writing, are possible only because of this gravitation. And the existence of our universe and our home, the solar system, is possible only because of this gravitation. The life creature on the earth is possible only because of the availability of suitable gravitational forces and conditions in our earth. We can't imagine our lives without gravitation for even a single second also. I hope you might have understood what are the importance of gravitation. Now let me show you the picture which shows our solar system. If we look at the picture of solar system, we can clearly note that the planets are revolving around the sun in their respective orbitals, which means these planets has their own type of motions, which can be termed as planetary motions. And these planetary motions has been explained by many scientists in past centuries. And now today we are going to discuss few of the theories which was explained by famous scientists about the planetary motions. In them, the very first one is the geocentric theory. This geocentric theory was proposed by Ptolemy in 6th century. And this theory also known as the earliest recorded model of planetary motion. In this theory, Ptolemy had said that all the planets revolve around the earth and earth is situated at the center of the solar system. As we can see in the picture, we are able to find few limitations. In the same way, in the past years, there is another scientist whose name is Nicholas Copernicus had proposed his heliocentric theory. In this heliocentric theory, he said that helio, which means the sun, is situated at the center of the solar system, and all other planets, including Earth, revolve around the sun in their circular orbits. Including these two scientists, there are many scientists in the world who had contributed their efforts on explaining the planetary motion. But in them, we need to know about a particular person, that is TTWREIS, who had spent his complete life on observing the positions of the celestial orbits and recording the data regarding his observations. But unfortunately, he was unsuccessful in explaining his data and theories and his observations. But one of his assistants, who is known as Johannes Kepler, had recollected the data of Brahe, and with more scientific reasoning and analysis, he was able to put forward the most elegant laws, which are famously known as Kepler's laws of planetary motion. Now, what is this Kepler's laws of planetary motions? These Kepler's laws of planetary motions are mainly meant for explaining the rotation of planets in the orbits. And these Kepler's laws of planetary motions are majorly calculated into three laws. In this law of orbits, Kepler had noted that all the planets revolve around the Sun in an elliptical orbit, with the Sun situated at the center or the foci of an ellipse. I think you are not clear with this first law. To understand this first law clearly, we need to know a simple term, that is elliptical orbit. What is elliptical orbit? Elliptical orbit is in the sense the orbit which resembles the shape of an egg and shape of an oval and contains two focuses in it and follows with geometrical condition is known as elliptical orbit. And there are few terms which we need to know from this elliptical orbit. Friends, if we consider an elliptical orbit and if we place a Sun at the one of the foci, then the point which is very nearer to the Sun on the orbit is known as ephelion, and the point which is far away from the Sun in the orbit is known as perihelion. And if we join these two lines, or if we join these 2 points, then the line is called as major axis. And if we term it as 2r, and if we draw a perpendicular bisector to these major axis, then that line is called as minor axis. And friends, if I need to know, and I need to propose another term, that is the tangent. Tangent is the line which joins the Sun and the planet. And friends, if we have the major axis, then it will be considered as semi-major axis, and it can be represented by r. Now, let me redefine what is Kepler's law of first motion. Kepler's law states that all the planets revolve around the Sun in an elliptical orbit, with the Sun situated at one of the foci of the ellipse. I hope it clears you. Now, let us move on to the Kepler's second law. Kepler's second law is also known as the law of area. Firstly, let me define what is this laws of area. The tangents of the planet with respect to Sun sweeps an equal amount of area in equal interval of time. This is known as law of area. If you look at the diagram, if we consider a Sun is situated at one of the foci and let it point C, and if we consider at an instant a planet is situated at point A, and in the time interval of 30 days, if it travels the distance from A to B, then the area which was formed by A, B, C is known as A1. And at another hand, if we consider the same planet is situated at the point of C, and at the same interval of 30 days, if it covers the distance of C to D, then the area formed by C, D, E is known as A2. And according to this law, we can state that these two areas will be equals. And the reason behind this law is, if we consider the Sun is at one of the foci, and if the planet is nearer to the Sun, it will travel very faster. In the same way, whenever the same planet is situated far away from the Sun, then it will travel very slow. By this reason, he had proposed that the area which was formed by those tangential pairs is known as are equal. I hope you are clear with me. Now, let us move on to the third law. Kepler's third law is also known as the law of period. Firstly, let me define what is Kepler's law of period. The square of the time period taken by the planet to revolve around the Sun is directly proportional to the cube of the semi-major axis. As we discussed earlier, semi-major axis represents r, which is half of the major axis, and we can represent the Kepler's third law as t square is directly proportional to the r cube, whereas t represents the time period taken by the planet to revolve around the Sun, and r is the distance between Sun and the planet. and if we add a constant term to the r cube, and if we bring the r cube to the left hand side, then it can be termed as t square by r cube is equals to k, whereas k is called as constant, and its constant value is similar for every 9 planets in our solar system. In this way, Kepler had proved his third law. I hope you are clear with these Kepler's laws of planetary motion. Now let us move on to the applications of this Kepler's law. As we discussed earlier, these laws are helpful for the explaining the orbits of the planets, and these laws are useful for predicting the orbits of different objects in the universe, such as like meteoroids, comets and asteroids, etc. And these laws also played a vital role in the discovery of dark matter in our Milky Way. And also these laws are played an important role in the arrival of the concept of universal law of gravitation by Sir Isaac Newton. Now let me pose you one question, friends. What is the similar thing that you had observed in this about the Kepler's law? Yes, it's absolutely correct. We can observe the rotation of the planets around the sun. Now the general question which always arises in everyone's mind is, why these planets are revolving around the sun constantly? Why they are not attracting towards the sun or not flying away from the sun? To answer these, we need to know two simple terms in physics, those are centrifugal force and centrifugal force. Now firstly, let me define what is centrifugal force. Centrifugal force can be defined as the force which is acting on an object which is rotating in a circular path and directed towards the center around which the object is moving. As you can see in the first picture, the tangent which represents into the center or towards the center is known as centripetal force. And according to Newton's third law of motion, for every action there will be exist an equal amount of opposite reaction. Is it in, friends? In the same way, for every force in the nature there will be exist an equal amount of counter force. For this centrifugal force, there is a counter force which is known as centrifugal force, and if you observe in the figure 2, it will be known as centrifugal force, and this centrifugal force can be stated as the force which arises from the static of an object and appears to be acting on the object which is moving in a circular path and directed away from the center around which it is moving. I hope you might have understood. Now if you look at the second picture, you can see that the centrifugal force is acting away from the center around which the object is moving. That is called as centrifugal force. Now let us discuss the examples of this centrifugal force and centrifugal force. Now if we consider the picture 1, in the picture 1 we can see that the car is rotating in a circular path, and if we consider the two cases, in first case if we neglect the centrifugal force which was acting on the car, then the centrifugal force which was acting on the car will be pull away the car around the center away from the center around which it is rotating. And if we consider the second case, if we neglect the centrifugal force, then the centripetal force which is acting on the car will pull the car towards the center around which it is rotating. But as you can see in the picture, the car continues its constant motion because it is experiencing both the centrifugal force and centrifugal force in equal magnitude. That's why it is moving in a constant circular motion. Now let us observe the second picture. In this picture, the boy is rotating on a circular wheel, and now let us consider the same laws or same cases. If we consider the first case, in first case if we neglect the centripetal force, then the centrifugal force which was acting on the body will be carry away the boy from the center. And if we consider in second case, if we consider in the second case, if we neglect the centrifugal force, then the centripetal force which is acting on the boy will be attract the boy towards the center around who was rotating. In this case, if any of the force will be neglected, then the boy will definitely falls down and get wounded. But as you can see in the picture, the boy is enjoying the rotation of the circular wheel because he was experiencing both the centripetal force and centrifugal force equally. I hope you might have understand what are the examples of the centripetal and centrifugal forces. Now let me tell you a small story. Once upon a time there was a man whose name is Isaac Newton. One day he was napping under an apple tree for getting relaxation from his work stress. On his sudden sight, he observed that an apple is falling from the top of the tree towards the ground. And one of the quick questions which arises in his mind is, why the apple is coming towards the ground and why don't it fly away into the sky? As we know that human mind has no limitation, he just put forwarded many questions regarding this phenomena, and by this phenomena Sir Isaac Newton has inspired to put forward the concept of universal law of gravitation. Now, what is this universal law of gravitation? Sir Isaac Newton had generalized this universal law of gravitation as the force of attraction between two any particles having masses is directly proportional to the product of their masses and inversely proportional to the product of square of their distance between them. I hope that makes you clear. But now the question is, how can we quantify the force of attraction between these two particles? For this, we generally use a mathematical term, that is capital F is equals to capital G into capital M into small m by r square. This is the general term which we use to calculate the force of attraction between two particles. Now, let me define each term in this equation. The capital M indicates the mass of the bigger object and small m indicates the mass of the smaller object, and r which indicates the distance between the two particles, and whereas G is called as universal law of gravitational constant, and this universal law of gravitation constant plays a special role in this equation. Now, what is this universal law of gravitation constant? It is the numerical value which is equals to the force of attraction between two particles which are kept at a unit distance apart, and its numerical value is almost equals to 6.67 into 10 to the power of minus 11 Newton meter square kg minus square. Now, the question is, why this universal law of gravitation is called as constant, which means the capital G is called as constant, because the value of this capital G is independent on any factors such as like the masses of the particle which are involving in the attraction and the distance between these particles which are in attraction. That is why the value of G, capital G, is always constant whether we take an object smaller or bigger in consideration, whether we take the measurement on the surface of the earth or surface of the moon. The value of capital G remains constant. Now, let us move to the uses of this universal law of gravitation constant. This universal law of gravitation is responsible for the existence of our solar system, and this universal law of gravitation is the reason for holding the atmosphere near the surface of the earth, and this universal law of gravitation is the reason for having rainfalls and snowfalls in the land. I hope you might understand what is the universal law of gravitation. Friends, now let me perform a small activity here. If we consider this as an object of mass and if we throw it vertically up into the sky, what will happen? I too don't know. Now let us see what will happen. Yes, it's absolutely coming back to my hand, isn't it, friends? And this is because of the earth gravitational pull. And whenever we throw an object of mass m vertically into the sky, it will attain its maximum height, and after that it will comes back to the ground, and whenever it coming back towards the ground, then it will be in the state of free falling, and the acceleration attained by any free falling object by the combination of gravitational force and centrifugal force is known as acceleration due to gravity. Now, let me define once again the acceleration due to gravity. The acceleration attained by any free falling object due to the combination of gravitational force and centrifugal force is known as acceleration due to gravity. Now, how can we quantify the value or the acceleration due to gravity between two objects? For this, we will generally use a mathematical term, that is small g is equals to capital G into capital M by r square, whereas r square indicates the distance between the two particles, capital M indicates the mass of the earth, and capital G indicates the universal law of gravitation constant, and small g indicates the acceleration due to gravity. Friends, did you notice it one point here? I am specializing these alphabetic letters as capital and small, and why I am doing it so? because if we don't specify them as capital or small, then the value of the expression or the meaning of the expression will be changes, because as we discussed earlier about the capital G, and now we are discussing about the small g. If we don't specialize them as capital G and small g, then there will be no difference between them. So make note that it is important to specialize the capital G and small g, or small or capital M or small m. Okay, I hope you might have understand this. Now let us summarize what we had discussed in our session. Firstly, we had discussed about the geocentric theory and the heliocentric theory, and then we had discussed about the Kepler's laws of planetary motion. In this Kepler's laws of planetary motion, we had majorly discussed about three laws. Those are the law of orbit, the law of area, and law of period, and we had discussed about the applications of this Kepler's law. And then we had discussed about the centripetal force and centrifugal force, what are those forces and examples of that forces. And then we had discussed about a small story of Isaac Newton, and then we had discussed about the concept of universal law of gravitation, and then we had performed a small activity, and then we had discussed about acceleration due to gravity. Now let me add a small point here. Now let me question you that, is the acceleration due to gravity value is constant everywhere in the universe? Yes, it is absolutely no. The value of acceleration due to gravity is not constant everywhere on the universe, because the value of this small g is dependent on certain factors such as like the masses of the particle which are involved in the attraction, and the distance between the particles which are involved in the attraction. As these factors are different for different objects, then the acceleration due to gravity will be different, or the value will be varies from one place to another place. Is it in, friends? Let me conclude my topic or our session as saying the uses of this gravitation and applications of this gravitation. This gravitation plays an important and key role in our day-to-day life. Whatever the work we are doing is because of this gravitation itself. We can't imagine our lives without the gravitation. Now it is time to conclude, and it's time to pay my gratitude towards our Honorable Secretary Sir Dr. R.S. Praveen Kumar Sir. And my special thanks goes to our college principal Lalu Sir and Vice Principal Mamata Madam, and our all college teachers and staff who had encouraged me a lot. And I would like to thank my mentor Sir Venugopal Sir and Lakshman Sir who had encouraged me for this presentation. And my special thanks goes to my friends who had encouraged me and showed an affection towards me. And I would like to thank our Telangana government who is providing such a wonderful opportunities for our tribal students. Now I would like to give my special thanks towards the TSAT who had showed such a patience on my presentation.